So this is an example to see how many energy servants is equal to the amount of energy produced by a typical residential solar photovoltaic system. And so we're using my house as an example of a residential solar photovoltaic system. So let's write this out. How many energy servants equivalent to a residential solar PV system? That's a system that generates electricity from sunlight. And we'll assume that the residential solar PV system is 40 kilowatt hours per day. That's actually a power. I did the same thing in class. It's generating 40 kilowatt hours. When I say per day, I'm dividing by time, so that's a power, energy per unit time. And we're assuming that that's a typical residential electric energy generation averaged over the course of a year. What is meant by an energy servant? One energy servant is equivalent to the amount of energy that is used by a human body in a day. So one energy servant is 2,000 calories with a big C per day. We also expressed that as about 100 watts. Notice that these are both power, energy per unit time. Watts is power, it's joules per second. So what we need to do is find out how many of these is equal to this. They're both expressed in terms of power. If we think of it in terms of energy per day, then I can just compare 2,000 calories to 40 kilowatt hours. So let's convert that 2,000 calories to kilowatt hours. Okay, so we do that. That's the energy of the servant, what the book calls an energy servant, which is just the energy equivalent of a human body, is 2,000, and that's calories with a capital C. That's the food calorie. I want to convert that to kilowatt hours. I don't remember that conversion off the top of my head, but what I do remember is that there are 4,000, oddly enough, I remember this, 4,184 joules in 1 calorie with a capital C. And so that gives me that the energy of an energy servant in 1 day is 2,000. Oh, let's see if my calculator will work here. 2,000 times 4,184 is 8.4 times 10 to the 6 joules. So that's the daily amount of energy in joules that it takes to keep our body going. If I want to convert that to kilowatt hours, I remember that a kilowatt hour is 1,000 watts for an hour, and an hour is 3,600 seconds. So 1 kilowatt hour is 1,000 watts times 3,600 seconds, and since a watt is 1,000 joules per second, then I can write it this way. The seconds cancel, I'm going to get an answer in joules. So 1 kilowatt hour is 1,000 times 3,600, or 3.6 times 10 to the 6 joules. So 40 kilowatt hours, so the energy of the solar system that I put in is 40 kilowatt hours, and that's 40 times that amount of energy for a single kilowatt hour, 3.6 times 10 to the 6 joules. So let's see what that is. 40 times 3.6 times 10 to the 6, and I'm not entirely sure how to do that. I think that worked out right. 1.44 times 10 to the 8 joules. So this particular residential solar system is generating 144 million joules of energy per day. It's the 40 kilowatt hours per day. 40 kilowatt hours became this many joules. One energy servant is about 8.4 million joules per day. So the number of servants is this number divided by this number. In other words, what do I have to multiply this number by, the energy servant number, in order to equal that? So it's 1.44 times 10 to the 8 divided by 8.4 times 10 to the 6. Those are both joules, and the joules will cancel. So if I take that and divide it by 8.4 times 10 to the 6, I get 17. So my residential solar power system is about equal to 17 energy servants in terms of the amount of energy that it'll be producing per day. There's 2 people living in my house, so that would be 8.5 energy servants worth per person. So if we're each an average American, meaning that we consume as much energy as 100 energy servants, then the solar photovoltaic system on our house is producing about 8.5% of our total energy consumption needs. If we live a more efficient lifestyle, maybe I only need 70 energy servants to satisfy my particular consumption of energy, then it would be a higher percentage. But anyhow, that gives an idea about how you go about that sort of estimation.